Some experts believe that 20% of freshwater fish have high levels of mercury that they are dangerous to eat. Okay? And it says, suppose a fish market has 250 fish tested. Okay, we test 250 fish are tested, and 60 have dangerous levels. And we want to know, test the hypothesis that this sample is not from a population with 20% different fish, okay? Is this sample from a different population? Okay, and it says use alpha equal to 0.05. All right, so if it came from a same population, so our null hypothesis is that it came from the same population, then the proportion of fish that were dangerous would be 20%. If it came from a different population, the proportion of dangerous fish would not equal 20%, okay? It just is different, so it's not saying that the population has more or less, so we're just going to do not equal to. So this means we've got a two-tailed test. Okay? Our test statistic. Alright, I guess I should check the conditions, okay, but we've got to assume that the fish were randomly selected, and it doesn't say that explicitly, okay? But we have to assume that this is true, otherwise we cannot do our test, okay? N times p, is that greater than 10? Yes. And is n times 1 minus p greater than 10? Yes. Okay, you can check it, okay? 20% times 250 and 80% times 250, both of those numbers are going to be greater than 10. Okay, and is it reasonable to believe that there's more than 2,500 fish total? More than 2,500 fish total? Sure, that also makes sense. Okay, so our conditions check out. So anyway, our test statistic is what we observed minus what is stated in the null hypothesis divided by our standard error. What did we observe? We observed 60 out of 250 fish have dangerous levels of mercury. So 60 divided by 250, that's a proportion of 24%, 0.24. So our test statistic is going to be 0.24 minus what our null hypothesis states, which is 0.20, divided by my standard error. So the standard error is going to come, we're going to use the number from our null hypothesis. So I'm going to have 0.20 times 1 minus 0.20. 1 minus 0.20 is 0.80. And I divide by the n, which is 250 fish. So here I've got 0.2 times 0.8 divided by 250. I take the square root of that, and I get 0.0253. Okay. So I have this 0.24 minus 0.2 divided by, and I'm just using the number in the calculator, so I don't even have to worry about rounding. And I get a z-score of 1.58. This is my z-score. This is my test statistic. So if I draw my picture centered at 0, I have a cutoff at 1.58, and it's a two-tailed test. Two-tailed test means I also look at negative 1.58, and I'm going to double the total area in the tails, okay? Or just double one of the tails so I get both tail areas, okay? Because this is a two-tailed test. So if I just look up negative 1.58, I can find out how much is in one tail. Negative 1.58 gives me 0.0571. I have 0.0571 in this tail, which means I also have 0.0571 in this tail. So my total tail area is equal to 0.05 0.0571 times 2, which gives me 0.1142. So my p-value is equal to 0.1142. And we are asking, we are going to use alpha 0.05. So here my p-value is greater than 0.05. So what is my conclusion? I do not reject the null hypothesis, which means I do not have evidence that the fish come from a different population. Or my proportion, the proportion that I observed is not significantly different of, I don't know, contaminated fish that I observed is not significantly different from 0.20. Okay, and that's it for that problem.